Imagine hitting deploy and instantly your entire server just goes dark.
Yeah, that is a terrifying feeling.
Right. I mean, you have no mouse, you have no draggable windows, no brightly lit little folder icons to like comfort you.
Just a black screen and a tiny blinking cursor.
Exactly. You're staring at this completely black screen, and somewhere out there, thousands of users are getting a 404 error on your web app.
Which is pretty much the ultimate nightmare for a developer.
It really is. You're completely alone in the command line wilderness. So today, we're going to teach you how to survive and, actually master that exact environment.
Because honestly, we are so accustomed to the visual intuition of modern computing. We like our digital spaces to be bright and forgiving.
Yeah, we want an undo button.
Exactly.
Perfect.
But when you step into pure server management, all of those safety nets just vanish.
Which is exactly why we're doing this deep dive. Our mission today is really specific, but it's incredibly empowering.
It's all about taking control.
Right. So say you have a brand new virtual private server, a VPS, and you need to deploy a complex GitHub project onto it so the world can actually use it.
But how do you do that if you aren't like a seasoned systems admin?
Yeah, if the command line just makes your palms sweat, we are going to walk you through the absolute essentials of server deployment.
We're breaking down how the infrastructure of the internet actually works behind the scenes.
And we're not just going to read you a dictionary of jargon. We're going to build a step-by-step narrative.
Right, taking you from a blank slate all the way to a production-ready web server that runs around the clock.
So let's start by framing exactly what we're dealing with here. Our sources use this brilliant conceptual model that I really want to unpack.
The apartment complex analogy, right?
Yes. We need to understand what a VPS actually is. Renting a VPS from a provider like DigitalOcean or AWS is fundamentally like renting a private flat in a massive data center apartment complex.
It is the perfect architectural analogy. I mean, the data center itself is the massive building.
With like shared electricity and security.
Exactly. Shared, massive fiber optic internet pipes. But your specific VPS, that is your private, isolated flat inside that building.
You have your own front door, which is your IP address, and you have your own locks.
But a lot of people wonder, why go through the trouble of renting this virtual apartment at all?
Right, like if I write a note app, why can't I just run it on the laptop sitting on my desk?
Well, it really comes down to availability. A developer's laptop is arguably the worst possible place to host an app.
Because it goes to sleep.
Exactly. The lid gets closed.
Yeah.
Your IP address changes the second you walk to a coffee shop.
Or, you accidentally spill coffee on the keyboard.
Precisely. But a VPS is an environment built for pure persistence.
Yep.
It literally never goes to sleep.
It's sitting in a climate-controlled room somewhere.
Right, with redundant power supplies connected directly to the internet backbone 24/7.
So as the listener, you are essentially stepping into the role of the property manager for this virtual flat.
You have to decorate it, secure it, keep things running.
But before we even walk up to the front door, we have to establish a major ground rule about this blank black terminal screen.
This is a huge psychological shift for beginners. The terminal is not a smart assistant.
It is literal to a fault.
Yes, it does exactly what you instruct it to do and absolutely nothing more.
It's not going to guess your intentions.
No, it won't autocorrect you. It rarely asks, "Are you sure?" If you tell it to delete its own operating system, it just does it instantly.
It gives you absolute power, but it demands absolute precision.
Right. Which brings us to our first real challenge.
Standing outside the apartment building, we have the unit number, the IP address, but how do we walk through the front door?
We have to use SSH.
And this is where things get super interesting. The command is simple, // username at IP address. But what about security?
Well, SSH stands for Secure Shell. It's the cryptographic protocol that lets you operate securely over the public internet.
Oh wait, if I just type that, it asks for a password. Are we really sending a raw password over the internet to another country?
If you were using the old system, Telnet, yes. And it would be catastrophic because it sent everything in plain text.
Yikes. So anyone could just read it.
Exactly.
Yeah.
SSH encrypts the connection. But you're right to be wary. Even encrypted, passwords are a massive liability.
Because bots can just guess them.
Right. They brute force the server thousands of times a second.
So if passwords are out, how do we prove we own the apartment?
This is where we introduce SSH key pairs, which use asymmetric cryptography.
I've always loved that term, asymmetric. How do the keys work?
Instead of a password, you generate two cryptographic files on your laptop, a public key and a private key.
Okay, so what's the public key like?
Think of the public key as a highly specific open padlock. You can make 1,000,000 copies of it. It contains no secrets.
So I could email it to someone and it's fine.
Totally fine. When you set up your VPS, you place one of these open padlocks on the inside of the server's front door.
In a file called authorized keys, right?
Exactly. Posh authorized keys. Now, the private key is the actual physical key that unlocks that specific padlock.
And what's the golden rule there?
The absolute unbreakable rule is that the private key never, ever leaves your local machine.
It just stays locked on your hard drive.
Yes, it is not transmitted over the internet.
But wait, if the private key isn't sent to the server, how does the server know it's me knocking?
This is the brilliance of a challenge response system. It establishes trust before the login happens.
Oh, like a cryptographic puzzle.
Exactly. When you try to connect, the server finds your public padlock and uses it to encrypt a random math puzzle.
And it sends that locked puzzle to my laptop.
Right. And the math guarantees that only the corresponding private key can unlock it.
So my laptop solves it and sends the answer back.
Precisely. The server sees the correct answer and says, "Okay, come on in. Your private key never left your computer."
That is just phenomenal engineering. But what about the server itself? Our sources talk about host verification.
Right, because proving who you are is only half the battle.
Yeah, what if I'm at a coffee shop and someone hijacked the router? What if they're impersonating the server to steal my keystrokes?
That's a man-in-the-middle attack. SSH anticipates this with a file called known hosts.
How does that work?
The very first time you connect to your VPS, your laptop downloads a unique cryptographic fingerprint of the server.
And it saves it in that known hosts file.
Yes. Every subsequent time you connect, it checks the fingerprint. If it changes by even one character, the connection halts.
It just throws up a massive, scary warning screen.
Exactly. It assumes the server is compromised and refuses to proceed.
Okay, so the cryptography works. We're inside the apartment, but it's pitch black.
Just a blinking cursor.
Right. On Windows, I see my C drive. Here, I have nothing. How do I orient myself?
That's why we need our first essential command, PWD.
Which functionally does what?
Print working directory tells you exactly where you are standing in the server's file system, functioning like asking a digital GPS map for your current coordinates.
So as an example, you'd use PWD the second you log in to confirm your location before accidentally creating files in the wrong place.
Exactly. It grounds you.
Yeah.
And it usually prints something like home SAMI or root.
Which brings up the whole Linux file structure. It's so alien compared to Windows.
Right. Linux discards drive letters entirely. Everything is one massive tree structure.
Starting at the root directory, which is just a single /.
Yes. Every path originates there. But this confuses beginners because the word root is overloaded.
Let's clear that up. What's the difference between the root directory, the /, and the folder named root?
Crucial distinction. This single slash is the base of the entire building. But the folder root is the personal home folder for the ultimate system administrator.
The landlord's private penthouse.
That's exactly right. But usually we log in as a normal tenant, a standard user.
So if my username is Sammy, where do I live?
Normal tenants live in home, so your path is home SAMI.
And typing that gets annoying, so there's a shortcut, right?
Yes, the tilde symbol. The little squiggly line always represents your current user's home directory.
Okay, so PDD gave us our GPS coordinates, but we still can't see the room's contents. We need to turn on the lights.
For that, we use our second command, .ls.
What's the core function of ls?
List displays all the files and folders in your current location, acting exactly like pulling open a physical drawer to see everything stored inside.
And for an example, you would type LAALA to check if a deeply hidden .env file actually downloaded to your server.
Right. But let's break down that LA flag.
Yeah, why not just type ls?
Because ls alone only shows visible files. Linux hides system files by starting their names with a period.
The dot files, it's like an invisibility cloak.
Exactly. To strip that cloak, you use the add flag for all. It shows absolutely everything.
And the LAL part.
That stands for long format. It generates a detailed dossier on every item.
Yeah.
Ownership, size, timestamps, and most importantly, permissions.
Ugh, Linux file permissions. Our sources really hammered this. When you run Elzala, you see this gibberish 10-character string like Nerger XRW XRWX.
It looks arcane, but the logic is elegant. Those 10 characters dictate exactly who can do what with that file.
Okay, what is the very first character on the far left?
That just shows the item type. ADD means it's a directory. A simple dash means it's a standard file.
That's easy. What about the other 9 characters?
They are divided into 3 blocks of 3. Owner permissions, group permissions, and world permissions.
And the letters inside those blocks.
Always are WX. Read, write, and execute.
So read means you can look at it, write means you can edit or delete it, and execute means you can run it as a program.
Precisely. And if a permission is missing, you just see a dash.
So ASREWXRWR means it's a file where the owner has full power, the group can read and write, and the public can only read.
You've got it perfectly.
But online, people always use numbers like 700 or 644. Is that a secret code?
It's just binary math. Read is 4, write is 2, execute is 1. You just add them up.
So if the owner has read, write, and execute, 4 plus 2 plus 1 is 7.
Right. And if they only have read and write, it's 6.
So 644 means the owner has 6, and the group and world both have 4, meaning read only.
Exactly. And 700 means the owner has full power, and no one else can even see the file.
Which is what SSH requires for your private keys, right?
Yes. If your permissions are too open, SSH will literally refuse to use your keys.
Built-in paranoia, I love it. Okay, so we can see the room. How do we walk to another room?
That's command number 3.
Functionally.
Change directory moves you into a new folder, serving as your virtual legs to transport you seamlessly across the file system.
As an example, you'd type CD with 2 periods to step backward 1 level if you walked into the wrong subdirectory.
Yes. And that brings up absolute versus relative paths.
Right. What's an absolute path?
It's the full GPS coordinate. It always starts with the root/arrow, like cd var www my project. It works from anywhere.
And a relative path.
It depends on where you currently are. If you're already in Varro, you just type cd my project.
It's like saying walk into the room on your left instead of giving the full street address.
Exactly.
Okay, we know how to walk around. Now we need to build things. Command 4. mkdir.
Make directory.
How does it work operationally?
Make directory constructs new empty folders, functioning exactly like framing out fresh, cleanly walled rooms inside your apartment to organize your belongings.
And for an example, you'd use mkdir my project inside your web folder to prepare a dedicated space for your GitHub code.
Right. And if you need to build a deeply nested folder structure, you don't have to run it multiple times.
You can use a flag, right?
Yes, the Dara P flag for parents. mkdir kg abc builds the entire family tree in one swift motion.
That's so efficient. But what if I make a mistake and need to delete a folder? There's no recycle bin.
No, there isn't. You have to use command5.rm.
Which does what to the file?
Remove severs the system's connection to a file, acting less like a trash can and more like throwing a document directly into a roaring incinerator.
So for an example, you use our oldconfig.js to eradicate an outdated file so it doesn't conflict with your app.
Yes. But let's clarify how that incinerator works. It doesn't overwrite your data with zeros immediately.
No, really? What does it do?
Linux tracks data using inodes, which are basically entries in a master ledger that point to the physical hard drive.
Okay.
When you type ARM, it just deletes the pointer from the ledger.
It just tears the page out of the index.
Exactly. The raw data is technically still there until the server overwrites it with something new. But practically it's gone.
And there's a super dangerous version of this command, right? rm-r?
Yes. The standard ARM refuses to delete folders. But the RO flag stands for recursive. It overrides the safety.
So it dives into a folder and deletes everything inside.
Everything. Files, subfolders, the parent folder. If you run airham-ashar in the root directory, your server will actively incinerate its own operating system while it's running.
It just eats itself until it dies. That is terrifying.
Which is why you always want backups.
Right. So how do we make backups? Command6.cp.
Copy.
What's the function?
Copy duplicates the contents of a file to a new destination, working exactly like running a crucial document through a photocopier to secure a safe backup.
So an example is typing cpa cpconfig.backup before you mess around with security settings, just so you have a pristine version to revert to.
Exactly. It takes a source and a destination.
What if we don't want a duplicate? We just want to move the file or rename it. That's command7.mv. Move.
Functionally speaking,
Move alters the directory pathway or the name of a file, performing a lightning-fast relabeling of the data's address without actually transporting the bytes.
as an example, you use mvindex.html var www my project to shift a file across the system into your public web folder.
Yes, and the reason it's so fast, even for huge files, is because it just updates that inode ledger we talked about.
It just rewrites the index label.
Right, which is also why moving a file and renaming a file use the exact same command.
You just type mv oldname.html newname.html.
Exactly. To the system, giving it a new path and a new name are the exact same operation. Okay, this is a major pivot point. We can navigate, we can move boxes around, but we can't see inside the boxes yet. We don't have Microsoft Word. How do we read a text file?
We start with Command 8. Cat.
What is cat doing?
Concatenate extracts the text payload of a file and dumps it into your terminal, much like aggressively unspooling a massive receipt on a table to view it all at once.
So, example, cat package.json to quickly check your project dependencies without risking an accidental edit.
Right. But cat is blunt force. If the file is 5,000 lines long, it just blurs past your eyes in a second.
You'd have to manually scroll way back up.
Which is annoying. So for long files, you actually want to use a pager program called Less.
Oh, so less file name paginates it.
Exactly. One screen at a time.
Yeah.
And you just press Q to quit when you're done.
Nice. But observation isn't enough. We need to write and change code. Command 9.nano.
My favorite text editor for beginners.
How does Nano integrate into our workflow?
Nano launches a visually distinct text editor embedded right inside your terminal, acting as an intuitive interface to modify system files using just your keyboard.
So you'd use nano-config as an example to manually alter security settings, make your changes, and save.
Right. And we use Nano specifically because it's safe.
Unlike Vim or Emacs, I see memes about people getting literally trapped inside Vim.
That's a very real meme. Vim uses modal editing. Pressing J might type a letter, or it might delete a whole paragraph, depending on what invisible mode you're in.
That sounds like a nightmare for a beginner.
It is. If you don't know the exact sequence of keystrokes to exit, it flat out refuses to let you out. But Nano is modless.
It just types what you press.
Yes. And it keeps a cheat sheet menu permanently displayed at the bottom of the screen.
It literally tells you that feature roll plus X exits.
Exactly. It removes the cognitive load.
Okay, so we can navigate, we can read, we can edit, we want to install Git and Node.js, but if we're a normal tenant, we aren't allowed to permanently alter the building. We need the landlord's keys.
Which brings us to the most famous command in Linux, command 10.sudo.
Super user do. How does it alter our context?
Sudo temporarily elevates your privileges to match the absolute system administrator, functioning as a high-security override key for structural alterations.
So for example, you prepend it to your editor, typing sudo nano etc config to forcefully unlock a protected file.
Right.
But why not just log in as the landlord from the start? Why not just be the root user all the time?
It violates the principle of least privilege. If you are root constantly, every typo has godlike authority.
If you accidentally type the incinerator command, it doesn't stop you.
Exactly. Or if a malicious script runs, it instantly hijacks the whole server. Sudo acts as a deliberate speed bump.
It forces you to pause, type your password, and think about what you're doing.
And it leaves an audit trail in the system logs.
Let's look at that example, securing the config file. Our sources call this a non-negotiable baseline. What are we changing?
You open it with sudo nano, and you find the directive called password authentication. You change it from yes to no.
Because we already set up our cryptographic keys.
Right. This makes your server completely invisible to bots trying to guess passwords.
And what about the root user?
You find permit root login and change that to no as well. You force everyone to log in as a normal user first.
Okay, we make the changes and press curl plus X to save. Are we secure instantly?
Not yet. You rewrote the manual, but the SSH daemon hasn't read it. You have to restart the service with sudo systemtessel restart sesh.
But wait, if I made a typo in the config and the service fails to restart, does the front door lock permanently?
Yes. You will be locked out of your own server.
How do I prevent that?
Never close your current terminal window when you restart SSH. Open a second window on your laptop and try to connect.
Ah, because the first window maintains an open pipeline.
Exactly. If the second window connects, you're safe. If it hangs, you just tab back to the first window, fix your typo, and try again.
That is a total lifesaver. All right, the apartment is locked down. Now we need tools. Command 11, apt update.
The intelligence briefing.
How does it function?
Apt Update synchronizes your local catalog with global repositories, acting as an intelligence briefing so your server knows exactly where to find the newest software versions.
Example, running sudo apt update the first time you boot your VPS to ensure your software list is current.
Right. But it's crucial to know the apt update doesn't actually install anything.
It just updates the menu.
Exactly. It just downloads the master manifest of available software.
So to actually order the software, we use command 12. Apt install.
What's the mechanical action there? Apt install fetches specific software and automatically unpacks all prerequisites, working like a logistics manager that delivers and assembles complex machinery for you.
So for example, sudo apt install get node.js npm. I equips your server to run your web app.
Right. And that fake Y flag is important.
It automatically answers yes to all the prompts, right?
Yes, otherwise the installation pauses halfway through to ask if you're sure you want to use the disk space.
Perfect for automated scripts. Okay, the server is equipped. Now we bring our code over. Command 13.get clone.
How does git clone work structurally? Git clone downloads an exact replica of a remote repository, providing your server with the complete, unbroken historical ledger of your entire project.
So example, git clone https.github.com myproject.git with a period at the end to unpack everything right into your current folder.
Yes, that period is a great trick. Without it, Git makes a brand new subfolder.
Our sources mentioned Git is a distributed version control system. What does distributed mean?
Older systems had one master server. If it crashed, nobody could see the history. Git changed that.
So when I clone it, I get everything.
Every commit, every branch, dating back to day one. Your VPS becomes a fully independent node.
That's incredibly resilient. But what happens when I fix a bug on my laptop a week later? How do I update the live server?
Command 14,
Git pull.
how does it execute the sync?
Git pull queries the remote repository for changes and merges new commits into your local environment, acting like a targeted synchronization wave for your code.
Example, running Git, pull on your VPS to instantly apply a security patch you just pushed to GitHub. Exactly. But doing that manually every time you fix a typo is agonizingly tedious.
Yeah, logging in, navigating folders, typing pull. There's a better way, right?
Yes, automatic deployment using a bare repository on the server.
What makes it bare?
It has no working directory, no text files you can edit. It's just the version control engine, listening for incoming code.
And how does that update the website?
You use Git hooks. You write a tiny script in a file called post-receive.
So it runs immediately after it receives code.
Right. The script basically says, hey Git, the second you get new code from my laptop, aggressively extract it directly into my live web directory.
So I bypass the manual pull entirely.
Exactly. You just type git push live on your laptop, and milliseconds later, your live website is updated.
It feels like magic. Okay, the code is there, but we need our external libraries. Command 15.npm install.
How does it acquire those materials? npm install parses your project's blueprint to fetch and integrate every third-party library, acting as an automated procurement system for your dependencies.
Example, running npm install to dynamically download thousands of files into a node modules folder so you don't have to store them on GitHub.
Right. It reads the package.json file, ensuring the server's environment perfectly matches your laptop's environment.
Preventing the classic "it worked on my machine" disaster.
Exactly.
All right, the infrastructure is complete. It's time to power up. Command 16.nodeapp.js.
What happens at the system level here? Node compiles and executes your JavaScript, essentially turning the ignition key and pumping electricity into your code to bring the server online.
Example, running nodeindex.js to verify your app connects to the network. But wait, if I close my laptop right after that, the SSH session dies, right?
Yes. And your node process is a child of that SSH session. When the parent dies, the operating system terminates all the children.
So my website just goes offline.
Instantly. Yeah. To fix this, you have to convert the app into a daemon.
A background process untethered from the terminal.
Right. And the industry standard tool for that is PM2.
Let's talk about PM2. You install it globally, and then instead of nodeapp.js, you type pm2 startapp.js.
And PM2 grabs your app, throws it in the background, and gives you your terminal prompt back.
It becomes a surrogate parent.
Yes. And it's a vigilant guardian. If your app crashes, PM2 automatically restarts it in milliseconds.
What if the whole server reboots?
You use PM2 save to freeze the state and PM2 startup to embed PM2 directly into the server's core boot sequence.
So it autonomously revives everything when the power comes back. That's incredible. And what about cluster mode?
Oh, that's magic. Node is single-threaded. If you have a massive 4-core server, it only uses 1 core by default.
Wasting all that hardware.
Exactly. But if you run PM2 startapp.js.imax, it analyzes your hardware and launches 4 parallel instances of your app.
And it acts as a load balancer.
Yes, distributing incoming web traffic across all 4 cores perfectly.
Mind blown. Okay, but what if things go wrong? We need diagnostic telemetry. Command 17.po.
How does it expose the system? PSO generates a snapshot of every active process, functioning precisely like an X-ray, exposing the hidden internal resource consumption of your machine.
Example, scanning the output to hunt down the process ID or PID of a crashed program.
Right. The A shows all users, the U shows CPU and memory usage, and the X reveals the hidden daemons.
Okay, so you find the rogue PID, let's say it's 1234. How do we kill it? Command 18, kill.
What is the underlying mechanism? Kill transmits termination signals directly to a process, allowing you to gracefully request a shutdown or violently pull the power plug.
Example, kill 1234 to forcefully terminate a frozen process. But you mentioned signals.
Right. By default, kill sends SIGTERM. It's a polite request to finish saving data and shut down.
And if the program ignores the polite request,
You escalate. You type kill neg-d9 1234, which sends SIGKILL.
the nuclear option.
It speaks directly to the terminal. It eradicates the process instantly, without warning. No saving allowed.
Use as a last resort. Okay, what if the whole server is just slow? We need an overview. Command 19, top.
How does TOP visualize performance? TOP provides a dynamic dashboard of system resources, operating exactly like the chaotic exhibiter screen in a restaurant kitchen, showing which orders are backing up.
Example, running top during a traffic spike to see if a database query is eating 99% of your RAM. And you press Q to exit.
Right. And the most crucial metric in TOP is the load average.
Those three numbers at the top, the 1, 5, and 15-minute averages, what do they mean?
Think of your CPU as a single-lane bridge. A load of 0.5 means the bridge is half full.
And 1.0.
Exactly, 100% capacity. It's full, but traffic is flowing.
So 2.0 is a traffic jam.
Exactly. But if you have a 4-core server, you have a 4-lane bridge. You don't hit max capacity until the load is 4.0.
That's amazing for predictive scaling.
Yeah.
Okay, the app is running, telemetry is good, final act, command 20, exit.
What is the technical mechanism? Exit gracefully commands the secure shell daemon to terminate your session, locking the deadbolt on your virtual apartment as you step away.
Example, typing exit when you're completely done for the day. But what if my Wi-Fi drops and the terminal just freezes?
The frozen terminal. You press enter, then the tilde symbol, then a period seal.
Enter, squiggly line, dot.
Yes, it's an intercept code. It forces your local laptop to sever the dead connection immediately.
And to prevent it from freezing in the first place.
You can set server live interval to 60 in your config file. Your laptop will autonomously send an invisible cryptographic ping every 60 seconds.
A digital heartbeat to keep the connection alive. And you can even use SSH multiplexing, right?
Yes. It lets multiple terminal windows secretly piggyback onto the exact same encrypted tunnel.
Bypassing the slow handshake every time you open a new tab.
It makes your workflow incredibly fluid.
Well, there we have it. We started with a terrifying black screen. We used cryptography to unlock the door. We navigated, built folders, locked down security, installed dependencies, cloned our code, and set up automated pipelines.
We hired a daemon to guard the app and used X-rays to ensure stability.
You took raw hardware and bent it entirely to your will.
Which brings me to a final thought. We are constantly bombarded with marketing about the cloud.
Like it's pure magic that mortals shouldn't touch.
Exactly. But there is no cloud. It's just someone else's physical computer sitting in a cold room in Virginia.
By mastering the terminal, you strip away that magic. You hold the master keys to the actual infrastructure of the internet.
The wilderness is entirely mapped. It's just a foundation waiting for you to build upon it.
So now that you possess the master keys, what will you build next?